What if someone could read the database memory without ever logging in? This is exactly what happened with MongoBleed, a vulnerability that was disclosed on December 19, 2025. In today's episode of Threat Talks The Deep Dive, we dive deep into MongoBleed and everything that goes with it. Let's get on to it.
Welcome to Threat Talks. Let's delve deep into the dynamic world of cybersecurity.
With me today is Luca Cipriano, our CTI and Red Team Program Lead. Welcome,
Hi.
Luca.
Thank you.
And my name is Rob Maas, Field CTO at Ontoit. So, first of all, of course, MongoDB. It sounds like a database, but what exactly is it?
Yeah, indeed. As the name suggests, it is a database. It is a NoSQL database, so it's a little bit different from normal database that people might be used.
Yeah, so like Microsoft SQL, for example.
Yes. So the difference here is that data is not stored as you would expect in rows and tables, for example, but it is stored in binary encoded version of JSON. So it is stored in documents that are created. This is because it allows to manage and query large volumes of data in a more flexible and scalable way.
So this also means that this database, this MongoDB, is often used in cloud environment, I can assume?
Yeah, indeed, it is, indeed.
So for the scalability,
Yeah.
Okay. You in the preparation, you said, okay, this whole vulnerability is based because MongoDB uses a different kind of protocol. Can you explain a bit about that?
So as you can imagine, as I mentioned before, it's different is a NoSQL, so already the database is different, but MongoDB also uses its own TCP based wire protocol, that does not use like normal HTTP, and it does not expose directly REST endpoints, but the client communication is done using this wire protocol.
Okay, this wire protocol also runs on a different port than normal HTTP would?
Yeah, of course, it's on its own port, and the difference here is that the messages are sent. Like for example, if you need to get data, if you need to carry this BSON data, you will use some message, like for example the OP_MSG, which is one of the message type that it can be sent with this protocol. Where the vulnerability is that this kind of protocol allows also to send compressed messages. In this case, you will send like an OP_compressed message via the wire protocol, and this kind of message allows as a field where it is specified the uncompressed size of the message.
Yeah, so this compression is normally used to save mainly bandwidth,
Yes,
to
indeed.
optimize the whole communication. And you say you can send compressed messages, and then in the message there is noted how big the message actually is.
Yeah, there is a field that will specify the size of the message after the compression. This is used also because MongoDB needs to allocate the buffer space for when the message gets decompressed. So basically, this message can be altered. So an attacker that wants to exploit this vulnerability, it will send a compressed message with a value in the uncompressed size that is bigger than it actually is. So explain it a bit easier. So I will send you a message and I will specify in the uncompressed size of the file is 1 megabyte. But actually in the message that I'm sending, the uncompressed size is 1 kilobyte.
Yeah, okay. So if you send me that message, I get the message. It's just 1 kilobyte, at least the real message.
After
but
the
I
compression,
think, after reading your packet, I think it's 1 megabyte.
Yes.
So I will probably reserve 1 megabyte for your message.
Yes, exactly. So you are going to reserve more space than it actually will be used.
Okay. And that's also so what happens. So I will send, if you were MongoDB, I will send you a compressed message, 1 KB of our real message.
Yeah.
And then I just say this is 1 megabyte.
Indeed.
And MongoDB will then reserve the space.
And this happens, of course, this sort of message and fields are used before authentication. So this is an unauthenticated vulnerability.
Okay, so this already happens before.
Yeah, because
at
that point, the database does not know the content of the message yet. It just knows, hey, this is compressed and it needs to be this space, and then it allocates that memory, and then it will start to look into the message and what it is.
Okay, so I already feel a bit where this is heading. So normally, if space is being allocated in programs, that space will completely be erased or zeroed out. So writing all zeros in order to prevent data from being leaked.
Yes, it depends in general, but yeah, it depends. In this case, as you mentioned, this does not happen. MongoDB is written in C++, and it's more like also for saving resources and making it a bit faster. Then the memory does not get zeroed every time. So in the actual extra space, that extra space will contain previous memory that has been used by the database.
Okay, so far I understand.
Previous data, in the memory,
yeah. So far I understand that space is being reserved.
Yes.
But if I was the attacker, I still haven't access to it. So we're still missing some pieces here.
Yes, indeed. So at this point, as an attacker, I will send you this compressed message. I will tell you, hey, when is decompressed is 1 megabyte, for example, and instead it is 1 kilobyte. And then at that point, MongoDB, it will allocate the memory. And how it works is that then it starts to examine the BSON data and the strings. And normally, strings are terminated with, they're null terminated. So there's a null byte that tells that string's terminated. Me as an attacker, I will add the fake size, but I also will not terminate the string. So when the message reaches MongoDB and it will parse the message, it will keep parsing all the memory until it finds a null byte, basically. And then it will know that string ends there. This is the problem because basically I don't terminate my string with a null byte. Parsing keeps occurring until the first null byte, and that string, it will be invalid because, of course, it will get an error because probably there's other data or exceed maximum size or for other reason.
You start reading the memory until it reaches a null byte or the end, of course, of the reservation.
And the null byte will be in the memory that was previously used on the newly allocated part of the memory. And then at that point, the MongoDB will output an error, and the error is a verbose error, and it will tell, hey, it's an invalid string, and it will output the string.
Okay. So everything, and the string in this case is everything that is read until
the null byte that has been found.
So that contains a lot of the previous data that was in the database.
And that previous data can be clear text password, credentials, API keys, PII, whatever. It can be anything.
But it also sounds like as an attacker, I can execute this attack. It's quite easy if I have access because I don't have to authenticate. Yes. I can read the database, but still, if I do this only once, I have to be very lucky to get something valuable out of it.
So this is like one of those kind of attacks. Like we've seen several bleed kind of attack, like Citrix bleed. We've discussed that also in the past. Those are kind of attack that you won't carry just once, but you will see a burst of attacks because, of course, you don't know what is there, so you need to kind of sort of brute force approach. And
it makes sense to me now. So you're bleeding the data.
Yes.
That's why they call it,
exactly.
In this case, MongoBleed. You need to do it several times.
Yeah.
And then just hoping that
you will find something at a certain point for sure. So, I mean, if you carry it a lot of time, then there's going to be something for sure in the data that you get.
Okay. Well, that makes sense. So it's quite, sounds like quite an easy attack to exploit.
Well, yes, indeed. Of course, it's one of those unauthenticated attacks. In general, you should not expose the port directly through internet. So unless there is a misconfiguration that you expose your MongoDB port directly to everybody through internet, this is something that an attacker might exploit more if it's in the network adjacent or on a machine that can communicate with that port. But yes, indeed, it's.
Yeah, I would say in general, it's a good idea to segment your network, and especially for these kind of services or servers that normally don't need direct access by humans, and only the application server needs access, you can make very strict firewall rules for it.
Yes.
But I also can imagine when it's often running in cloud, that people can easily make a mistake and make it publicly accessible.
Yeah, that's of course misconfiguration can happen for human mistakes. That happens often. So indeed.
Also, you said it's the bleeding part, so you need to kind of burst to get the correct data out of it. So you need to do it a couple of times. It sounds to me that should also be easy to detect.
Yeah, well, I mean that is an indication. If you look at, for example, if you have a burst of session or connection within a specific time frame, that is an indication that somebody is trying to exploit it. And of course, if you were vulnerable, it's worth thinking that you're being compromised because you don't know what data might have been leaked. In general, it depends, but you don't know. So it is a good indicator if you see like bursts.
But the downside, of course, is if you detect these bursts, that there is already some data out of your network, and you need to figure out. You have no idea what it is actually.
No, indeed, exactly. So, but,
the other thing that was a requirement in order to exploit this vulnerability was using the compression message type.
Of course, because you send a compressed message, that is something that can be disabled. So you could, for example, as a preventive measure, disable the zlib or other compression mechanism that are within MongoDB, and then you don't have anymore the problem of the memory allocation.
Okay, yeah. So I can imagine this might have an impact on performance.
Indeed.
Is there also, because it was disclosed on December the 19th, is there already a patch available?
There's a patch that they released it with a patch. So of course you should patch as soon as possible if you're running a vulnerable version. That is something that is the first thing.
Yeah, that sounds like the first step to me.
Indeed.
All the other things
when
are
a patch
good to
is
do.
available, always patch.
Yeah. Okay. I think, is there anything else that we missed on this whole vulnerability?
No, I just would say like, if you think that you have been hit by this, you see like this burst of connection, you know that maybe the port was exposed or it comes from internal. I will suggest to think as if you have been compromised. So if there's any API keys or credentials, just rotate them because you don't know.
Yeah, you don't know what data was in there.
Yeah, and maybe this happened also really long ago. You see maybe the burst 1 month ago or whatever. So, but just assume that you have been compromised and the credentials have been leaked. It's always better.
Okay, that makes sense. So, as a wrap up, so if you run MongoBleed, first check if you are vulnerable. Maybe you already have patched. And then also think about the other measures that you can take. So the network segmentation, make sure that MongoBleed is only reachable by mainly application servers that really should have access to it.
Yes.
Well, if patching is not an option, you might consider disabling the compression on the wire protocol, so that also prevents abuse. And monitor if you see anything abnormal happening to your MongoDB, especially burst of connections. Burst of connections. And with that, I would like to thank you, Luca, for this insight. And to you listeners, thank you for watching. I hope you like what you saw. And please like and subscribe. It helps us to spread the word further. Thank you.
Thank you for listening to Threat Talks, a podcast by Onto It Cybersecurity and AMS-IX. Did you like what you heard? Do you want to learn more? Follow Threat Talks to stay up to date on the topic of cybersecurity.